Today's lesson is on literal equations. So what is a literal equation? A literal equation is an equation that mainly consists of variables or letters. It may contain numbers, but it primarily consists of variables. So for our first example, we have 5b plus 12c equals 9, and we're going to solve that for b. So just like we did in our equations where we only had one variable, we're going to ask ourselves, where is our variable? It's on the left-hand side of the equal sign. And then what's happening to b? It's being multiplied by 5, and we're also adding 12c. So remember, we work those order of operations in reverse order. So we're going to undo the adding 12c with subtracting 12c. So if I subtract 12c from the left, I also have to subtract 12c from the right-hand side. So we do know that 12c minus 12c cancels out. We're going to bring down the 5b. We're going to bring down the equal sign. And 9 and 12c are not like terms, so we cannot combine them. We cannot take 9 minus 12 and say we have negative 3c. 9 is a constant because it does not have a variable attached to it. 12c has a variable attached to it, so they are not like terms. And then we're going to undo that multiplying by 5 with a dividing by 5. And we do have to divide the entire side by 5. We can't just divide 9 by 5 or the negative 12c by 5. We have to divide everything by 5. So our final answer for b, because now b is by itself, b is equivalent to 9 minus 12c all divided by 5. Now, we do need to look at another form of this. It is okay if the 12c comes first. You just take the sign that's in front. So you might see this written as negative 12c. The 9 is positive, so that would be plus 9 all divided by 5. There's also a third way you can see this. You can split that numerator as long as both terms are over a 5. We can look at that as 9/5 minus 12/5 c, or negative 12/5 c plus 9/5. So those are all equivalent ways to write that. So you only have to do one, but just know that if you're taking like a multiple choice test, those all mean the same exact thing. So if we look at example B, we're taking 2x minus 17y equals 13, and we're going to solve for y. So we ask ourselves, where is y? Y is on the left-hand side. What things are happening? Well, it's being added by 2x and being multiplied by negative 17. So again, we're going to undo the addition first with subtraction. So I'm going to subtract 2x from both sides of the equal sign. I do know that 2x minus 2x cancels, and we're going to bring down the negative 17y. We're going to bring down the equal sign, and then we're going to bring down, I'm going to write down my negative 2x first and my positive 13 second. It doesn't matter, you can also do 13 minus 2x, both are acceptable. And then the last step would be to divide by negative 17, because the y is connected to negative 17 by multiplication, so we would divide, and we divide that whole side by negative 17. So our first option, we could say that y is equivalent to negative 2x plus 13 all over negative 17. Or if you wrote down the 13 first, that's fine. Then you would have minus 2x all over negative 17. And again, we could split those. Negative 2 over negative 17. Now you do have to know a negative over a negative is a positive. So we could also see this as 2/17 x. And then a positive 13 over a negative 17 would be a negative, and that would be minus 13/17. Or if you wrote it the other way, you would have negative 13/17 plus 2/17 x. So you can write that any of those 4 ways and it's technically correct. For example C, we have 28 equals t times the quantity of r plus 4. So if we look at this, we're solving for t, and this one's kind of unique because t is actually connected to the parentheses by multiplication. And so really the only step we have to do is if the t is connected to the parentheses by multiplication, we simply can do the opposite of multiplying, which would be to divide by whatever's in the parenthesis. So our r plus 4s are going to cancel, and we end up with 28 over r plus 4 equals t. Now, we do have another way to write that. We could, again, split that up, and we could say 28 over r plus 28 over 4, but then we would have to simplify 28/4, and 28/4 would be 7. So you would have 28 over r plus 7 would be equal to t. So that one you have 2 ways to write it. 1 and 2. And letter D, we're going to solve for k. So we have k minus 2 all over 5 equals 11j. So if we notice on this one, the k is in the numerator on the left. It's being subtracted by 2 and then divided by 5. Now this is the one that has the long division bar that kind of acts as a grouping symbol. So we're actually going to undo the division first with multiplication. So we're going to multiply both sides by 5. And we get k minus 2 equals 55j. And then k is still connected to the 2 by subtraction. So we're going to undo subtraction with addition. And 55j and a positive 2 are not like terms. So we can either write this as 55j plus 2, or you could write that as 2 plus 55j. So you have 2 ways to write that as well. And then we have E, which says solve the following equation for Q. Notice Q is inside the parentheses. So we're going to deal with what is outside the parentheses first. We're going to deal with the A. The A is connected by multiplication. So the inverse of multiplication would be to divide. So we're going to get rid of the A by division. So we now have Q minus 8 equals 23 divided by A. And then you'll notice the Q is connected to 8 by subtraction, and the opposite of subtraction would be addition. So we're going to add 8 to both sides. And we end up with Q, so now Q is by itself, equals 23 over A plus 8. Or you could do 8 plus 23 over A. And last but not least, we have letter F. We're going to solve for H. So notice that H is connected to a half and a B by multiplication. You can do this all at one time, or you can do it separately. So it's totally up to you. I'm going to do it separately just so you understand what's happening to each piece of this. The H is connected to the B by multiplication, and we know the opposite of multiplication is division. So to get rid of the B, we're going to divide. So I now have A divided by B equals 1/2 H. And then we know that the H is connected to the 1/2 by multiplication, and the inverse of multiplication is division. But when we divide by fractions, we really multiply by the reciprocal. So we're really multiplying by 2 over 1 so that our 1/2 cancels out, and we're left with 2a over b equals h. That is how we solve literal equations.